Good morning, students. Welcome to video lecture class on control engineering. So today we'll start with the problems on root locus. So the statement is obtain the root locus plot for the system whose open loop transfer function is given as g of s into h of s is equal to k divided by s into s plus 5 into s plus 10. So here the given problem is in the standard format, that is g of s into h of s. If it is not, you have to convert that one into this standard format. So the very first step is you need to identify the number of poles and number of zeros. So the poles are nothing but the terms which are in the denominator, and zeros are nothing but the terms which are in the numerator. So here, to identify the poles and zeros, they must associate it with s as the function. So here in the denominator you are having three terms. S is separate, s plus 5 is one term, and s plus 10 is one term. So likewise the number of poles is 3, and zeros are nothing but the terms which are in the denominator. There is no s term in the denominator. K is a constant here, so number of zeros are, that is z value is 0. After that you need to identify which are those poles and the values of the poles and zeros. So first you equate this term to 0, s equal to 0, that means the first pole value is 0. Then s plus 5 equal to 0, from that you will get the value of s as minus 5. Similarly s plus 10 equal to 0, from that you will get the value of s as minus 10. So the poles are here 0, minus 5 and minus 10, and zeros are, the number of z is 0, so it is none. Now you have to compare the p number of p's with number of z. So here the p is greater than 0, therefore the number of root locus branches are equal to p value, that is 3. Instead of p as greater, if you are having zeros as 4, that time number of root locus branches will be 4. So once you identify the number of poles and their values and the number of root locus branches, the second step is you need to identify the root locus part and non-root locus part. So first on this s plane, just you draw x and y. The x value, x axis is name it as real, and y axis you name it as imaginary. So on this plane you first to mark the poles and zeros. So poles are 0, minus 5, 10. So 0, minus 5 and minus 10. Zeros are none. Okay. Now you need to identify the number of poles, the root locus part and non-root locus part. So for that, between this 0 and minus 5 you consider a reference plane. Towards right side of that reference plane you have to take the summation of p and z. If you take the reference plane here, towards right side means this side. So here number of poles are, only one pole is there which is at 0, and there are no zeros. So the summation of p and z will be 1, so it is an odd number. So from 0 to minus 5 it is a root locus part. Similarly, between minus 5 and minus 10 you consider a reference plane. Towards right side you take the summation of p and z. So if I take the reference plane here, towards right side means there are two poles, minus 5 and 0. So the summation will be 2. 2 means it is an even number. When the summation of p and z is even, that portion becomes NRL, that is non-root locus. Then consider a reference plane between minus 10 and infinity. Then take the summation of p and z towards right side here. So there are three poles, minus 10, minus 5, 0. So the sum will be 3. That means it is an odd number. So after minus 10 till infinity, it is a root locus part. Then the third step is, according to the rules, axis between 0 and minus 5 is part of RL, and axis between minus 5 and minus 10 is NRL, and axis left to the pole, that is minus 10, is RL. So now starting points are poles. Since zeros are not there, so p minus z you have to consider. P minus z is equal to 3 minus 0, which is equal to 3. So this is the number of branches approaches to infinity. That means to take the difference between P and Z, whatever the value you will get, that value you have to consider it as the number of branches which are approaching or which are tending to infinity. So that number is equal to the number of asymptotes required. Once you identify the number of asymptotes, the next fourth step is you have to calculate angle for those asymptotes. For that we are having the formula here, theta equal to 2q plus 1 into 180 degree divided by p minus z, where this q should start from 0. So here the required asymptotes are 3. So you can substitute 0, 1 and 2. So if you substitute q as 0, you will get theta 1 as 60 degree. If you substitute q as 1, you get theta 2 as 180 degree. If you substitute q as 2, you get theta 3 as 300 degree. So once you calculate the angle for the asymptotes, now you need to identify the centroid for the asymptote. For that also we are having the formula sigma equal to summation of real part of poles minus summation of real part of zeros divided by p minus z. So the summation is for the real part of the poles 0 plus minus 5, then plus is minus 10 minus 0, because here the number of zeros is none, so minus 0 divided by 3. So now if you simplify this, you will get sigma as minus 5. So that is the centroid. This here. Minus 5 is the centroid. From there you need to mark those angles for the asymptotes. One angle is 60 degree, second angle theta 2 is 180 degree, and third one is 300 degree. So here remember angles measured in counterclockwise direction. That is, you have to consider the positive angles. Then the sixth step is, according to the general prediction, one breakaway point exists between 0 and minus 5. Because always the breakaway point will lie on RL part, but you have to find out the exact location of that. So for that you have to consider the characteristic equation, that is 1 plus g of s into h of s equal to 0. So 1 plus this term he has given, k divided by s into s plus 5 into s plus 10 equal to 0. So if simplify this to get the equation for k, so k equal to minus s cube minus 15s square minus 50s. Now differentiate this equation with respect to s and equate that one to 0, that is dk by ds equal to 0. So if you differentiate that, you will get minus 3s square minus 30s minus 50 equal to 0, or you can take the negative sign as common, you can write it as 3s square plus 30s plus 50 equal to 0. Now you need to identify the roots for this equation. So if you determine the roots for this equation, you will get the roots as one root as minus 2.113 and one is minus 7.88. So now you have to check whether these values lie on RL or NRL, that is on root locus portion or NRL portion. So we know that from 0 to minus 5 it is a root locus part. So here minus 2.113, obviously it is a valid breakaway point. Similarly, if you check this one, it is minus 7.88, but here minus 5 to minus 10 it is NRL. So that point is lying on NRL portion, so it is not a valid breakaway point. Otherwise, you can substitute this s equal to minus 2.113 in equation number 2, that is in k equation. If we get this k value as a positive, you can take that root as the valid breakaway point. If you substitute s as minus 7.88, doesn't lie already from the general prediction, doesn't lie on 0 to 0 and minus 5 and after minus 10. So straight away we can reject that point as the not a valid breakaway point. But still, if you want to cross verify, you substitute s as minus 7.88 in this equation, that is for the k equation. So we will get k as minus 48.112. So that is a negative value you will get. So it is not a valid breakaway point. Then asymptotes are cutting imaginary axis here. So root locus branches also cuts the imaginary axis. Here we have already marked three angles, 60 degrees cutting and 300 degrees cutting the imaginary axis. So we need to identify the intersection of root locus with the imaginary axis. So for that we have to consider this roots array. So the characteristic equation is s cube plus 15s square plus 50s plus k equal to 0. That is from equation number 1. That is from here. Consider this equation as the characteristic equation. Then you construct this roots array. So the highest degree is s cube, s square, s raised to 1 and 0. Write the consecutive terms. For this the coefficient is 1. Skip this. The second one is 50 and here it is 0. Similarly, consider this s square. S for s square the coefficient is 15. For that you have to skip this to take this one. That is like this you have to take 15k0. And for s raised to 1 to write this one you cannot start from here because already you have considered that. So for that you cross multiply this 15 into 50 minus 1 into k divided by this term, immediate next above term you have to write. Similarly here if you want to write k into 0 will be 0, 50 into 0 will be 0, so this term will be 0. For this s raised to 0 we take this one as a. 15 into 0 will be 0 minus this term into this. So we'll take this one as a, the remaining terms as it is, a into k minus 15 into 0. 15 into 0 will be 0. So a into k divided by a. So we will left with the k here. So now s raised to 0 cannot be 0. So I will consider this term to equate to 0. So that is 15 into 50 minus k divided by 15 equal to 0. From that you will get k as 750, which you can take it as k marginal value. Now the auxiliary equation you have to consider. For that immediate the above row you have to consider. So that one will be 15s square plus k equal to 0. That is the auxiliary equation. So you will substitute that k margin value in this equation. You will get s as plus or minus 7.071 j. So this is the point of intersection of the root locus with imaginary axis. For that, the 8th step here means there are no complex poles or zeros. No need to find out the angle of departure and angle of arrival, because the very first step here, these all are real poles and zeros are none. If you are having the complex poles or complex zeros, that time you have to carry out this 8th step. That is, you need to calculate angle of departure or angle of arrival. So after that, the 9th step is you have to construct the root locus. So first, real axis, imaginary axis, mark the poles and zeros. 0, minus 5, minus 10. There are no zeros. Then mark the centroid. That is, centroid value is minus 5. From there you have to mark the angles 60 degree, 180 degree and 300 degree. After that you need to identify the breakaway point. So here the valid breakaway point is minus 2.11. Okay. So now you need to mark the, or you need to draw the root locus. So always starting points are poles and ending points are zeros. Okay. Since there are no zeros, so all the roots will tend to infinity. And you mark the intersection with imaginary axis minus 7.07j plus, and this is minus 7.07j. So start from the first root will start from 0. It will come up to this breakaway point which is at minus 2.11. Then it will tend to infinity followed by this asymptote and having the intersection at 7.07j. Similarly, the second root will start from minus 5 and it will come to this breakaway point. Then it will tend to infinity, followed by this asymptote which is at 300 degree and having the intersection with imaginary axis at minus 7.07 j. Similarly, third one is starting at minus 10, since you cannot move in this direction because this is the NRL part, and you are having one asymptote as 180 degree only. So it will start from minus 10 and it will tend to infinity by having the coincidence with this real axis only. This is the third branch. So that is at breakaway point minus 2.11, two branches approaching, one from pole 0 and another from minus 5. So RL leave at a breakaway point at an angle plus or minus 180 degree divided by 2, that is plus or minus 90 degree. First branch starts from a pole 0, reaches a breakaway point at minus 2.11, leaves at 90 degree plus 90 degree and ends at infinity along the asymptote at 60 degree. This is the branch. Similarly, second branch starts from a pole at minus 5, reaches a breakaway point at minus 2.11, leaves at minus 90 degree and ends to infinity along the asymptote 300 degrees. Similarly, third one starts from a pole minus 10 and ends at infinity along the asymptote at 180 degree. For this one, no breakaway point. The last step, that is 10th step, is you need to comment on its stability. Already you have calculated the marginal value for the K. So if your K value is between 0 and 750, your system is stable. If the K value is 750, the system is marginally stable. If the K value is greater than 750, system is unstable. This last comment is very important because already you have calculated this marginal value in your solution. Just you need to write these conditions: when your system is stable, when your system is marginally stable, and when your system is unstable. So you try to remember all these 10 steps and you have to apply all the 10 steps to all the problems. Only thing is that 8th step, if you are having the complex poles or complex zeros, only that time you need to carry out that 8th step. Otherwise you can skip that step. If you are having any doubt, you can leave the comment in comment box. Thank you.